Good morning. We are going to take a look at the bell ringer, but before we do that, I would appreciate it if you would please log in and type your name and ID number when prompted. As a review from yesterday, we're going to find the volume of the following prism, which is a hexagonal prism, so its bases are hexagons, and they are 10 units apart. So the height of our prism is 10. We need to find the area of the base, which is a hexagon. We know that each side length is 12. And when we divide 360 by our 6 sides, we learn that we have an isosceles triangle with a vertex angle of 60 degrees or an equilateral triangle. We'll draw the altitude of our hexagon, we'll draw the altitude of our triangle so we can find the area of the triangle and then multiply that by 6. So we have a 30, 60, 90 right triangle with our the side opposite the 30 is 6, and you can use your shortcut. Because this is a hexagon, we are not going to use trig. So the height of our isosceles triangle is 6 square root 3. So to find the area of this isosceles triangle, 1/2 base times height, we'll get an area of 36 square root 3 square centimeters. To find the area of the whole hexagon, we multiply that by 6. Now that we know the area of our base, we're going to use the volume formula, area of the base times height. So area of the base times height, 216 square root 3 times 10. Or we get our final answer of 2,160 square root 3 cubic centimeters. So if you have not gotten the notes packet yet, why don't you pause to get the notes packet so we can continue with finding the area of pyramids and cones. So today we are going to find the volume of pyramid and cones. And it is very much like finding the volume of a prism or cylinder, except you take 1/3 the area of the base times the perpendicular height of your pyramid or cone. Regardless, we still need to find area of the base, and from dead center of our square pyramid to the tippy top of the pyramid, that height is going to be 8. Each side is 12, so the area of the base is 144 square units. Remember, to find volume, it is 1/3 area of the base times height, so we will get a final answer of 384 cubic units. For the cone, what is the height of the cone? 12. From dead center up to the top, the height is 12. We need the area of the base, which is 25 pi. We will use our volume formula, 1/3 area of the base times height, and we will get a final answer of 100 pi cubic units. For problem C, we are going to do the problem backwards. As I have frequently mentioned, any geometry problem without a picture is a bad geometry problem. So I have drawn a cone with a radius of 6 yards. I remember my volume formula is 1/3 area of the base times height. The area of my base is 36 pi. Next, I plug in the numbers that I know. I know my total volume was 120 pi, and I've got the rest. I do algebra, 1/3 times 36 is 12 pi. Divide both sides by 12 pi. We will get that the height is 10 yards. On the next page, we will look at the volume addition postulate, which pretty much says you can break up a solid into more convenient parts and then add or subtract as needed. As we look at our first problem, my general plan is going to find the volume of the top and then the volume of the bottom. And since we're dealing with a cube, all sides are 3 units. Our tick marks indicate we have sides lengths of 3. So my bottom base is actually a 6 by 6 square. So let's focus on the area of the top. Let's focus on the volume of the top. The area of the base would be 9. It has a height of 3. Our volume is 27 cubic units. For our bottom, it also has a height of 3, but its base is going to be 36 square units. So we'll have a total volume of 108 cubic units. We add the two together, and the volume of the total shape is 135 cubic units. For the next problem, we are looking at a cylinder with a hole drilled out of it. My plan is going to find the volume of the whole cylinder and then subtract out the volume of the smaller inside cylinder. So my larger cylinder has the radius of 5, its height is 12. The area of the base is 25 pi. The total volume of our outer, larger cylinder is 300 pi cubic inches. I will look at our smaller cylinder with the radius of 3 and height of 12. The area of its base is 9 pi. And it will have a volume of 108 pi cubic inches. My original plan was to subtract the big from the small. So our final answer would be 192 pi cubic inches.